Welcome to my YouTube channel. In this short video lecture, we're going to discuss the method of secant of solving nonlinear equations. So in this class, we'll simply derive the method, and then the next video we'll do example to apply the method. So let's go into the class. So remember, a secant is any line passing through 2 points of a curve. So this is how we derive the method. So consider a function y equals to f of x passing through the points P and Q as shown below. The graph below. So let's draw the graph. So this is the y-axis, this is the x-axis. So this is a line x equals to 0. So let this be the graph. Or this is the function y equals to f of x. So consider a function y f of x with secant or simply a line passing through points P and Q on the graph as shown below. So let's draw the line. So this is the point Q, and then this is the point P. So let the value here be xn, let the value here be xn, and then this point be xn minus 1. I'll let the point where the graph has the x-axis, let it be xn plus 1. So this line PQ is such that this point xn can actually be read from the graph. And then this point, we can also read the value of the function from the graph. So let's also consider another, let P1 be the point on the graph whose value of x is xn. So this is what I mean, that we have this point here. So there's a point here, which we are calling P1. So where when you draw perpendicular from xn, then this way you have P1. So this implies that coordinates of P1 will be given by xn, comma f of xn, because the function defining this graph is y equals f of x. So from this, because this point xn minus 1 on the x-axis is the same point at P here. So then the coordinates of P are, so the value of x is xn minus 1, and then because it's on the graph, then the function value is f of xn minus 1. So next step, draw another secant. Remember, secant means a line passing through 2 points on a graph. So another secant from P through P1. So this is what I mean. That we draw another secant from this point P here on this point here, then passing through this point P1 where we have the value of x, xn, and then f of xn. So this is how the secant will look like. So we are drawing so this the secant PP1, and then as you can see from the diagram, this remember the root from this diagram, it implies that f of xn plus 1 is 0, because that's where the x value on the x-axis. So which means that xn plus 1 is the root of the function, or a 0 of the function. So the objective is to draw as many secant lines as possible from the point P towards the point, let me call this point, say, point R, the point where the graph of the x-axis. So from point P at the top of the graph here, so we are drawing secant lines to the graph from P towards the point R, so that we can approximate the root or the value at which the function attains the value 0 on the x-axis. So this is like the motion that we are trying to draw secant lines from this point xn minus 1 f of xn minus 1 towards the point xn plus 1, which is the exact root of the function. So through P1. So therefore, so the point P has coordinates xn minus 1, f of xn minus 1. And then the point P1, as we have seen, we have point xn, f of xn. So therefore, the gradient of the secant P1 is, if you remember what you did in Form 2, gradient is changing over change in x. So therefore, let's denote this gradient by m, which is the same as change in y over change in x. So the y value here, we have f, and say f of xn minus 1, the y value here, minus f of xn, the y value at P1, divided by x value here is x n minus 1 minus xn. So call this one equation 1. So this is the gradient of the secant. So we are trying to approximate the root of the function by a secant drawn from point P then to other points on the graph which are closer to the point R. So from Newton-Raphson method, we know that xn plus 1 is given by xn minus f of xn divided by f prime of xn. So let's call this one equation 2. So remember, derivative is a change in over change in x, which is the same as the gradient. So let's make the derivative the subject of the formula in this case. So this means that f of xn equals 2. So I have, or I can say, yes, f of xn equals to f prime of xn into xn plus 1 minus xn. And then it's a negative sign here. So I'm simply multiplying, taking this to the left-hand side, and then I multiply through by f prime of xn, and then I divide through by negative sign. That's why I have this. So next step, this means that minus f of xn prime is the same as f of xn divided by xn plus 1 minus xn. Or the same thing as saying f prime of xn equals to, so I divide 2 by negative, so I can write this one as negative f of xn divided by xn plus 1 minus xn. So call this one equation 3. Now, remember equation 1 is defining the gradient of the secant, which is approximating the value of x1. So therefore, equation 1, change in over change in x is the same as the derivative. Then this equation 2 is also an approximation of the derivative. So this means that equation 1 is approximately equals to equation 3 because all of them are defining the change in over change in x. So therefore, we equate equation 1 and equation 2. So this will be minus f of xn divided by xn plus 1 minus xn. is equals to, this one was f of xn minus 1, f of xn minus 1 minus f of xn divided by xn minus 1 minus xn minus xn xn. So then let's multiply through by to remove to make xn plus 1 the subject. So I'll have minus xn minus 1 minus xn divided by f of xn equals to xn plus 1 minus xn into f of xn minus 1 minus f of xn. So opening the brackets will give us xn f of xn and then minus xn minus 1 f of xn equals to xn plus 1 into f of xn minus 1 minus f of xn, and then so we have now minus xn times this one here. So minus xn into f of xn minus 1 minus f of xn. So this one I take it to the left hand side, so I'll have xn plus 1 into f of xn minus 1 minus f of xn equals to, so this one will give me xn f of xn minus xn minus 1 f of xn. Taking this one now will be positive, so plus xn f of xn minus 1 and then minus xn f of xn. So some terms will cancel out. So this term and this term will cancel out, so that we remain with xn plus 1 into f of xn minus 1 minus f of xn equals 2. So I can start with xn f of xn minus 1 minus xn minus 1 f of xn. And then to make xn plus 1 the subject, then we divide through by this bracket. So next step, we divide through by f of xn minus 1 minus f of xn divided through by f of xn minus 1 minus f of xn, so that this and this cancels out, and then xn plus 1 becomes xn f of xn minus 1 minus xn minus 1 f of xn divided by f of xn minus 1 minus f of xn. So this is the formula. So this is the second method formula. Or if you multiply both the numerator and denominator by negative sign, the same formula can be written as xn n plus 1 equals 2. So this will be now positive, xn minus 1 f of xn minus xn f of xn minus 1 divided by f of xn minus f of xn minus 1. So you can either use this or use this other representation here. So these two are what defines the secant method formula. So to use the formula, remember, just a key note, to apply the secant method, it's very key to apply the secant method. You need two initial approximations. Say x0 and x1. Unlike the other method where initial value is just one value, this one you only apply it if you have the first two initial approximations. So that is the derivation of the formula. So in the next video, we'll do an example on how to apply this formula. Thank you.